But today, we're going to go back over what we covered and start talking about some new things. So last time we talked about clonable. I think that's where we started. I have memory of a goldfish, so I don't actually know where we started, but I think it was at clonable.
Yeah.
So we talked about clonable. We talked about exceptions. We talked about the use of GitHub. We started to talk about JUnit, about unit tests, and I think we got all the way through this. And we're ready to start tackling the, hopefully, maybe the last day of review. We will see how far we get. Questions on anything that we just went over before we start talking about enums? All right, who's seen or heard of an enum before and knows what they are? Half the class-ish. So enums are incredibly useful when we want to describe a set of potential variable instantiations in an easier to see, easier to understand code. So enums underneath the hood are just stored as integers, but you can do something like a pizza status as an enum. So you could declare something like public enum pizza status. And underneath the hood, this is just stored as the integers 0, 1, and 2. But imagine in your code, you would say something like if pizza status equals 0, if it were stored as an integer, what does that mean? How readable is a pizza status being 0? There's no interpretation to that. It's not easy to read or understand. So you can use an enum to say something like if pizza status equals ordered, and now suddenly you have a nice English way and a nice readable way in your code to see whether or not what the status actually is. And you have words associated with that rather than numbers. And words are almost always better than numbers whenever you're describing something. So reasons you might care to use an enum. Code readability is the main one, because moving forward in your education, you're not going to be the only person reading your code. You're going to be writing code that other people who work on the same project are going to be reading. You're going to be reading their code, and future you, if you're me and have the memory of a goldfish, I don't know what code I wrote this morning, let alone what I wrote 2 or 3 years ago. If I look back at it and can't read it, that's going to be a problem. It's going to take me more time to figure out what my code does than is necessary. It's worth taking just a couple minutes when you write the code to make sure that every time in the future you go back to reference it. If it's you, if it's somebody else, it's readable. Allows for things like compile time checking, which is very nice. So you can actually check whether or not it adheres to ordered, ready, or delivered, 0, 1, or 2. If it's an int, ints can be any value. You could have an int that is a value 5. But no pizza status can have an underlying int 5 stored with it. It's either 0, 1, or 2. Nothing outside of those bounds are allowed. And so if you store this as an int, there'd be an arbitrary number of values you could set pizza status to that have no associated logic with it. And it would be much better or easier if we just use the enum, restrict the domain to 0, 1, and 2. You know the list of acceptable values right up front. Wherever you define the enum, you know that the only possible values for pizza status are ordered, ready, and delivered. If someone tries to set pizza status to, I don't know, currently being, what's something that doesn't make sense with a pizza? Shot out of a cannon? Pizza status equals cannon shot. That's not going to work because it's not part of the legal values that it can take based on the enum. So it also avoids the unexpected behavior. Talked about this from invalid values. So Here would be one of an equivalent piece of code that you could write, int pizza status, and then in a comment somewhere, you say 0 for ordered, 1 for ready, 2 for delivered. And whenever you're going to access this later in your code, you say, pizza status equals 1. You either need an additional comment that reminds the person who's reading this code, this means ready, or something of the sort. It's just much less readable. You need so many more comments to make it readable. Comment bloat is something that is unnecessary. We'll talk about this when we talk about code smells later on in the quarter. But you want to minimize comments in your code, not because you don't want to write comments, but you want your code to be the comment wherever possible. The comments should be at the top of methods, at the top of classes that tell you generically, what does this thing do? Your code should be readable enough that you don't need additional explanation that goes along with it. Questions on enums? All right, we're going to talk very briefly about iterators. So if you have a collection, an iterator, it's actually its own design pattern. It's not one of the design patterns we're going to cover in the course, but it is technically a design pattern. It helps you in looping through a collection. If you have a collection, let's say you have either an array list or a linked list or any other collection type that you've seen before, there is really strange behavior associated with if you're trying to make modifications to that collection while you're looping through it. Has anyone in here ever tried to remove from a linked list in the middle of a for each loop? I asked the same question in data structures this morning, but has anyone ever tried to do this? It doesn't go well. Why do you think that makes sense? Why wouldn't it go well?
I forget if it's array, it's hard to take.
It has to do with the associated indices, right? Whenever you remove from an array list or a linked list, the associated indices of everything that comes after that in the list all shift forward. So if you're looping through it and it's based on the index, then when you move to the next index, if you remove something, the next thing that you want to check is actually the same index again, because what was the next element is shifted forward to the current index. If you add to it, then the next thing you want to check is the index after it, or sorry, 2 after it, not 1 after it. And so that associated, you need extra logic to be able to do that. It's not defined within the concept of a for each loop. So because of this, we have a structure that helps with this and handles it for us. So we don't need to use an iterator. We only need them for collections if we're going to add to them or remove from them during iteration. So if you're only reading values from a collection and not changing your collection on the fly, you do not need an iterator. This is why things like a for each loop works if you're just trying to do things like print out the values in an array list or print out the values in a linked list. You do not need an iterator. It's not that complicated. But you will need to use an iterator to avoid a concurrent modification exception if you add to or remove from a collection while you're iterating it. And we talked about this, it's changing size while you're iterating, and you need to know, there's additional logic to know where the next element that you want to consider is, because your code doesn't know whether you're adding or removing. You could be doing either, or both, or a bunch of one. You could add, and then try to move forward, and that won't work. So the syntax for you to get an iterator, if you're using a built-in collection, what I mean by that is if you're importing Java's already existing array list or linked list or any other kind of collection that is covered in data structures, so things like stacks, queues, hash tables, any other kind of collection, then each one of those comes with a pre-made iterator method. So you can make an iterator with the associated class name in angle brackets. The typical name for an iterator is just called it. And then you have your instance, whatever your instance variable name is, so maybe you make an array list of type integer list. This would be list.iterator, and that will grab you an iterator for that, and then you can start to use it dot something. The methods that you care about are next and has next, which you might have seen before with things like scanners, if you're trying to determine if there's another token to read in an input stream. Have we seen that before with scanners? Needing to use has next and next. So it's very similar with an iterator. This will determine whether there's another thing for the iterator to go grab from the collection, and if so, it will actually go grab it from the collection. And built into these next and has next methods are the actual logic associated with removing and adding to. One thing to note is you can't call remove followed by remove, even if you have an iterator. You actually need to call next before you're able to remove after you've removed once. So it kind of becomes a ping pong of has next, next, remove, has next, next, remove. And that's how you can do things like remove. If you try to remove, you're going to get an exception related to your iterator. Questions about iterators? All right, next thing we might care about, this is going to come when we talk about actually commenting your code. We will start caring about preconditions and postconditions. Who here has heard of preconditions or postconditions before? Some people, that's good. So a precondition is something that has to be true before a particular code segment. So let's say you want to remove from a list. What would an associated precondition be to be able to successfully remove from a list?
It has to have something in it.
Yeah, it can't be empty, right? So this would be something that we would want to check before we just attempt to blindly remove from a list. So think of it, it goes very well with exceptions and very well with the if statements that you write at the very beginning of a method to check whether or not you can actually do the associated logic before you just assume that you can do the associated logic. So another example would be the value of some object that we pass in can't be null. If it is null, then we're going to try to dereference null and we'll get a null pointer exception. It would be much better if we could just pass back, we were not able to do what you asked me to do rather than crash your program. So if it is null, we should do something like return false or return 0, some kind of error message that says that we weren't able to do it, or we should throw a null pointer exception and allow the client to be able to do something about that exception if they so care. So best answer, throw a null pointer exception. A post condition, on the other hand, is something that has to be true after some code segment actually finishes running. So this is usually true after a method or some code segment, it's usually a method. So for instance, a post condition to calling a sort method on a list of integers is that the list is now sorted in numerical order. If you write a sort method that violates this post condition, have you actually sorted the list? No. So your post conditions tell your client, your user of your code, what they can expect if they call this method, and it does not throw an exception. Does this make sense? Questions about post conditions?
Is it kind of like a try catch kind of block sometimes where?
Yeah, so that's you offload that onto the client. Whenever you write a driver program, you're gonna have a try catch that says attempt to do this, and if doing this causes an exception, you can catch the exception so that your program doesn't crash. But when you're writing a piece of code, you don't worry about the try catch, you just worry about throwing the exception, and that makes sure that you're communicating to the user that something went wrong, but you're not trying to tell them what to do about it. something went wrong. It's outside of your purview what they want to do. That's gonna depend on what they need their application for. Maybe they just want their program to crash. Maybe they want to throw this into a try catch and loop until it's successful. That's on the client to figure out. JavaDoc is the official comment style for the Java programming language, and it's going to be useful to know and to start implementing for everything that every program that you write in Java. So it will be necessary for this class. I will be requiring that people use JavaDoc, and this is mainly because everything that you make in this class, I want you to be able to throw on GitHub and be useful in a job interview or internship interview type setting. So all submitted programs will follow the associated comment specifications. There is a comment that will precede every class, every field, every constructor, and every method that's not a constructor. The comment begins, instead of a normal block comment like /*, you will start it with /**. And in any IDE, it will change the color of the associated comment to show that this is a JavaDoc comment and not a regular comment. Regular comments are green usually in most IDEs, and JavaDoc is often blue. So I can even give you an example of this if I switch over to something like my linked list that we're writing in data structures. So if I wanted to write a JavaDoc comment for this isEmpty method, I could type / star is somewhere, ***, and you can see that here we're green, here we're blue, and get out of here. And if you have any associated parameters, it'll actually start to autofill these. So let's actually go up to something that actually has them. So if I do that ahead of /**, then you can even get some autofilling in some IDEs. Actually, I don't know if Eclipse does this or not, but you can start now autofilling this comment. And there are many programs that will actually look for this associated kind of like Control F, look for this, and you can embed that into other applications that use and look for these kinds of comments. So it's very useful if you're writing in Java to write a JavaDoc comment. So things that go in a JavaDoc comment. The first thing you should include is a very high-level description in English about what this thing does. So remember, it goes with a class or a field or a constructor or a method. You should describe, if it's the class JavaDoc comment, what is the purpose of this class? What does it do? What is the object? This should be no longer than a sentence. 2 at the absolute most for something that's very complicated. Keep it very high level. Don't go into a ton of detail about it. Just give them an idea of here's what this is, so they can determine this is what I want or this is not what I want. Second, you're going to list each parameter on a separate line in a way that looks like this. If there are no parameters, you just skip this section. The @ symbol comes before everything that is associated with one of these. So you say @param, that says that what follows is the name of a parameter. And then again, give a very, very brief description of the purpose of that parameter. What is it? Where is it coming from? What are the associated values that it can take? This should be probably a sentence fragment. I wouldn't even call this a complete sentence. I say a complete sentence is the longest it should be. Again, so it's very brief, but it orients the user that says, if you're looking at the method signature, what are each one of these components? What do these parameters represent? What should I be passing them? Next, you're gonna list every precondition. You can use at precondition, or you can use something like this with an associated description. If you don't have any preconditions, you will skip it. So here you have at precondition and a description of the precondition. Again, this should probably be something like a sentence fragment, a sentence at most. If there's a return value, you need to describe what the user can expect back from the method. If there's no return for something like a constructor or a void return for a method, you do not need this. You will have at return description of what gets returned from that. Finally, you'll list post conditions. One way, and I'll totally accept this throughout this class, if instead of preconditions, since preconditions are linked directly, basically to exceptions that get thrown, you can also use the at throws, list the name of the exception, and then list the behavior that throws that exception. And that can be done in place of preconditions. So this should probably be at throws and not at exceptions. I'm gonna make that change. So this should be at throws, the exception name and the reason that the exception might be thrown.
Is this all contained like within the comment that precedes the?
Yeah, this is all between the /** and the // that's in blue, that is the Java comment. So all of this will be done for every method, every constructor. It's very annoying to actually go write that, but that's the level of professional documentation that is expected from industry code. So we're gonna start switching to, we're just trying to make sure that it works, to we wanna start documenting and creating industry level code so that when you go into an interview, you pull up the code, when it says, show me some code that you've written, you pull this up and they go, oh, wow, it's already documented to our standard, or it looks like they care about documentation. They're not just writing code to get it to work. They actually care to go back and reference this. This is code that they plan to use. They care about this code enough that it's good enough, they will use it in the future, or they're gonna pass it off to somebody else to use it. This is the level of documentation that is expected if you're going to publish code. So we talked about everything except for the java.comment that goes at the top of each file. At the top of each file, you will have @author followed by your name. You will have an @collaborator, and you can list here anyone else in the class that you collaborated with on your code. This does not mean that you copied their code, of course, but if you discussed things like, how did you handle this particular thing that I'm having difficulty with? And your friend says something like, oh, I just did this at a very high level. That's a level of collaboration that I like to see and the TA for the course likes to see. This just says that the things that share in common between these two files, yeah, they're not exactly the same, but they look kind of similar because you talked about it. That's perfectly fine. This becomes the way that you document who you worked with. Remember that if you don't have a collaborator, you just did everything by yourself, you do not need to include @collaborator, but it's very useful for just documenting who did I work with on this. And in the future, if you have a question about it or want to reach back out, there's the name of the collaborator right there. You open up this file and you know who to reach out to talk to about it. You'll want to have an @date for the current date and an @course. This will help ground you in the future to say something like, oh, I wrote this while I was taking design patterns. That'll be very useful when you have 20 CS courses under your belt and you wrote a bunch of different programs for each one of them. This tells you where you were in the program when you wrote it. You'll look back when you're taking 400 level courses and you'll probably facepalm and say, why did I write this like this? I was such a naive programmer back then. It's fun to do. I still have some of my old code. It's disgusting. Questions about JavaDoc before we move on to other things? All right, another very oftenly confused idea. This concept of the keyword static. Who has knowledge about what static means in Java?
It's like, it doesn't change easily.
So that's a good way to put it, that's a good basic way to put it, sure. Does anyone have anything to expand upon for, it doesn't,
You don't need to, like, instantiate you don't need like an object in order to use like a static method, right?
okay, that's a good way to think about it too, I actually like that a lot. So, yeah, static basically means that every instantiation of the object refers to a centralized location. When you make something like a person object, and then you make another person object, all of the fields and all of the methods exist separately in memory. If you make a static method, it's saying rather than copying that logic into each instantiation of that object, there's gonna be a centralized place, and everywhere we refer to it in different objects is always going to refer to the same thing. So here we have person one, we'll use the same examples as last time, and here's person two. And they have a bunch of fields that are separate, and they have some methods that are separate. So well, let's say one of these methods is static. So we have somewhere that is the generic person blueprint, right? This is the person class. And some client code somewhere actually went and instantiated this. We can think of this kind of like a blueprint. And then as we instantiate that blueprint, we get actual different objects. So it would be something like looking at the Catalyst building blueprint. Is that a building? No, it's a description of a building. If you handed the Catalyst building's blueprint to an engineering company, a construction company, they could produce a Catalyst building. Voila, we actually have a building that we are in front of. So this is the instantiation of the blueprint of the Catalyst building. We could then say, do it again, make another Catalyst building over there, and we could have an exact mirror copy of this building somewhere else. And if we make a change, or I punch a hole in the floor of this Catalyst building, please don't do that. We pay a lot for this building. It would not affect the other building, and vice versa. They're two separate buildings, even though they're constructed from the same blueprint. But let's say there was something in common that we wanted between those, that one of them could reference. Maybe there's a single IT department that services both Catalyst buildings. Then inside of that, there would be, in the blueprint, there would be this place for the IT. And then when we want to access the IT department from either one of these, they're going to point to the same place in the person object. So rather than duplicating this, it's just going to be a reference to where it is in the actual blueprint that defines what this thing is. So no matter how many person objects we have, if this particular method is static, it'll refer back to a single piece of code right here that does not get duplicated for each object. Has anyone received the can't access a static reference from a non-static environment error or something of the sort? How do you think that arises? What does that mean? Yeah,
Because I'm guessing that would kind of be like the outside of, analogy, I guess, would be like an outside building's the same, it's like, oh, blueprint. Building,
yeah.
but the rooms are different, the doors.
So this arises because this is one of the detriments of Java. Everything in Java is a class. Even if you write a class called main, it's a class, which means that you can instantiate it. It has a default constructor. You can make main objects after you make a class called main. So what exists in a public static void main is this is just a list of things to do. It says do this, then do this, then do this, then do this. And if you try to access something that is duplicated amongst each person object, so maybe we have a jump. Person one is an Olympian and they can jump really, really high. Person two is me. I cannot jump very, very high. So if somewhere in a public static void main somewhere, so this has that keyword static in it, you were to say something like person.jump. This is referring to the code that tells for a generic person, how do you jump? But how person one jumps and how person two jumps is different. So it doesn't know which one of these you're referring to since they're separate jumps. It just means that there's some ambiguity there and it cannot resolve that ambiguity because there are multiple jumps. There's not one single jump. If you made jump a static method, then all people would jump exactly the same way at exactly the same height, and it would all refer back to here. And then when we try to say person.jump, it doesn't matter which person you mean, it all refers back to the same static jump, and there's no ambiguity anymore. Does that make sense? Hopefully that helps to alleviate some of the errors that you get from that. But static is an incredibly difficult concept for Java programmers, and it's kind of Java specific because Java makes this assumption that everything is a class. It's a necessity as part of Java's overall design, is that everything is an object. So one of the downsides of that is we have to be very careful with the keyword static. So you want to use the keyword static if every instantiation of that object uses exactly the same code. It does not vary at all and cannot vary between different instantiations of that object. If you have a field that is static, that means it's the same value for every instantiation of that object. It's still changeable. So there's a big difference between the keyword static and the keyword final. Final means that it cannot be modified at all for any reason. Static means if you change it for person one, it'll also change for person two because they're referring to the same thing. It's very similar to that concept of shallow copy from yesterday. There's only one instance of that field and all objects refer to that same place in memory. So person one's, I don't know, we could call this a static name. All people have the same name. There's a single place in memory that represents here is what name is. And even though person one has a name, it points here. Even though person two has a name, it points here, if name is static. I should probably make sure that I write the word static here. You can call person one's name, you can call person two's name, but you modify one, it'll modify them all, because it's static.
So, in that situation, how we control the change? Are we gonna control the change from, like the person class from the blueprint?
Yeah. Yeah, when you make the design decision for what is this field, you're gonna make a decision. You're either going to say something like private string name, or you're gonna say private static string name. One or the other of these. If you do the first one, each person has their own separate name. If you use the second one, everyone shares a name in common. This uses a single string worth of memory. This duplicates this for every object that is instantiated. Does that make sense? I find that static is super confusing to people, and so I make sure that however I can at the start of a class, I want to make sure that that concept of static is very clear. Any other questions about static? I want to spend as much time on this as it takes to make sure that people have an understanding. So if you have any questions about it, or even just an I don't get it, please let me know so that this will alleviate many headaches in the remainder of this course. Everyone good with what's on the board? Want to do a race? All right. Another way to think about it, since I've described it on the board, I now get to relearn what I wrote in my slides a quarter ago. Every phone has an on or off button. Another way to think about static, the on and off button on your phone only operates your phone. If the designer of the phone object had made the on-off button static, there would be a centralized on-off button that controls every instantiated phone. You press that, everyone's phone turns on. You press it again, everyone's phone turns off. That's weird and creepy. So the behavior that you would expect that defines this behavior is internal to each phone object, which means that it should not be static. So you can make a static field, you can make a static method. It's just a matter of does it change between each object, or is there centralized logic or centralized storage for each object? So an example of when you might want to use static is if, let's say, the registration department wants to create a student object for all students who attend Eastern Washington University. That should be made static because everyone who attends Eastern Washington University obviously attends Eastern Washington University and not some other school. So we don't want to duplicate the memory that's required to store Eastern Washington University for every single student object in the university. We can make it static, make it a single place in memory, and have every student object refer to that single string. It saves memory. One last thing we should probably talk about, we did say that main and driver classes are static when you make a public static void main. Why is that?
I think without that centralized logic, I don't think the main and the driver classes would really work that exact same way.
Yeah.
It'd make a huge mess.
Yeah, it is a huge mess. If you take out that word static, suddenly there's ambiguity. If you make multiple main objects, because everything in Java is an object, you make two different main objects. Now there are two different mains. When you click run, what do? You run the class 1's main or the class 2's main. Even though they're the same thing, there's still ambiguity about which one you run. So the word static means that there's only one main method. When you go to run your code, there's only one place it can start. There's no ambiguity. And then we did talk about this already. Questions about the static keyword? Anything last minute that I can clear up? You'll run into this during labs in this course as well.
Wait.
Yeah,
That is, you want stuff to keep the same property.
yeah,
If you want stuff that different properties, turn that off.
yeah, exactly.
So you don't want everyone's supposed to have separate on and off, but it's not the exact same one.
Yes.
Because that'd be wrong so many levels.
It'd be really weird, wouldn't it? Weird world we live in. As programmers, we have that level of control and power where when we define a phone object, we can decide to make the on-off button static or not. It's important to know what it does so that you don't accidentally make a single control for all phones. Java packages. Have we used package structure in prior classes and know what packages are used for, their relevance, why we would care to use them? We'll go over it at a basic level. So packages help group related classes together. The idea is we're gonna start talking about testing, but we want classes and the associated tests that you write for those classes to all be in the same package that are related to each other. So things like inheritance hierarchies, where we have a superclass and some number of subclasses. Those should all be in the same package because the subclasses refer to the superclass, might call the superclass constructor. They're related in some way, so they should be grouped together. One thing to note, you can have classes that are the same name as long as they are in separate packages, but you cannot name two classes the same thing within the same package, because then there's ambiguity. So this helps you if you have a really large multi-hundred class project that you're working on, it adds some additional structure. But it also means that we can introduce a new privacy modifier. We've seen public before, if we want anyone to be able to access that field or method. We have seen private before, if we don't want anything outside of the current class to be able to access that field or method. But there's an additional privacy modifier called protected that allows anything, any class in the same package, public access to that field or method. Does that make sense? So if we have, for instance, a linked list helper method, and in the same package, we have different linked list implementations. We have a singly linked list, we have a doubly linked list, we have a circular doubly linked list, and all of those are separate classes, and all of them together want to share the same helper method that does something. We could write that in one class and use the keyword protected, and then all different linked lists could all refer to that same code, and you would avoid duplicating it in every linked list instantiation. So it's the exact same as public, as long as the calling class is in the same package. And it's exactly the same as private to all classes that are outside of the current package. If you want to import this, you can just, whenever you have your own code and you want to reuse it, you can import project.package.class, and that allows you access to any functionality of the imported object. So let's say we want to import the protected method in a linked list class. We could just import the linked list class that has that method, and then we can freely call that method from within the current class. It's exactly the same thing you do with any of Java's built-in stuff that comes with Java itself. Questions about packages, the protected privacy modifier, importing your own code. It's great for code reuse. Don't redo something you've already done. Jar files. Have we exported anything as a jar before in any prior class? A few people? So a Java program has an extension .jar. A jar is an archived Java, so it's smaller than the files that are your classes. But you can create a jar, view a jar, extract a jar into the source code, and run an application directly from a jar. So it's just an extension that says this is an archived Java project that can be run. You can export it via any integrated development environment that has the export command. So if you're running in IntelliJ or Eclipse, both of those, if you just go to File, Export, you can export as a jar. You can also do this directly from the command line, not just from an IDE. So if you're in a Linux environment, or you just get used to using Windows PowerShell or Linux's Bash, any command line application, then you can just create the jar right there and run a Java project from the command line as well, and launching your IDE, launching IntelliJ, and then going and doing that. So the command line can often save you a lot of time, but just like before, it's nice. Questions on jar files, what they are? Last thing, we are going to get through this today, which is great. We're going to cover application programming interfaces, APIs. You've been coding to an API, but starting probably in the next course in the sequence, which is software engineering, you're gonna start making your own APIs, which are very useful. So who knows what an API actually is, or can give me a description of what an API is, what its purpose is? Yeah,
Is it the high level definition or description of what the class or method does?
yeah. Yeah, so when you make your own code, you want there to be some kind of high level documentation, the kinds of things that might go in a Java doc. But if you actually go to something like Java's API, you can see something like every method and how to use every method in every class that you might care about. So it describes how to use the tools that's written by somebody else. We're now transitioning from where you're using code that other people wrote to starting to write your own code that other people are going to use. That's the difference between a novice programmer and an expert programmer. Can you write your own tools that other people want to use? So Java's API tells you how to use everything, every built-in tool that comes with Java. So the scanner object, the file object, the iterator object, the null pointer exception object. Every tool you've ever imported at all from the Java library has an associated API page. There's an important distinction between using something and implementing it. So in this class, for labs just like in 210 and 211, I provide the API, you write the code to the API specification, but starting in software engineering, you're going to be creating your own classes and you're going to need to be able to provide the documentation for that. There's an important thing to point out when you're making your own API. What do you think happens? So let's actually go to the Java API. I don't even have a browser open. All right, here's the entirety of the Java API. You can see that there are just a few tools for you to use. Java is a very big language, lots of things that you can do, but let's select one that we know. Let's go ahead and find something like the scanner. Anyone want to take a guess at how many lines the scanner class actually is? We could actually look up the actual scanner class. There's the scanner class. So you can see that it tells you how to instantiate a scanner object, how to call some of these scanners methods. And as we scroll down this massive page, we can start to see here are all of the different constructors that you can use that instantiate a scanner. Here are all of the methods that a scanner contains. You can click on any of these and it'll take you later in the page. So for instance, what does the has next of a scanner do? Well, here we go. It returns a Boolean. It takes no parameters. It gives you a high level description that you might expect to be something like this is what would be in the Java doc comment. Returns true if this scanner has another token in its input. Method may block while waiting for input to scan. The scanner does not advance past any input. Tells you exactly what it does and how it works. What happens if you make a change to your API after the fact? Let's say I decide that the has next method needs a parameter. What happens to every poor soul who has next in their code somewhere? It breaks. It is incredibly important when you design an API, you make it extendable, but it cannot be modified for any reason. You can deprecate some things and say, we don't support this functionality anymore, but you do not want to go make changes to your API because you discover that your API sucks. and that you actually should have done it a different way. When you make the API, it's very finalized, and people who use it will yell at you if you change it after the fact. I actually had this happen in an interview setting once. I was a young, naive idiot once, and I went blindly into an interview with a C++ project that I had coded 2 years before. Did I test it ahead of time? No. Would it have worked if C++ hadn't changed its API? Yes. Had C++ changed its API between then? Yes. Did my program work in the middle of that interview? No. Did I get that job? No. Changing your API makes very angry people. I still hold this against C++ to this day. I hate the language solely because of that.
Really? Say that C++ changed it and your program went from perfectly functional to screw you, I'm not working.
Yes, so it creates very angry people.
And if you're your fault, it will work fine without the game.
Yes. So I will see you all tomorrow for our fun programming problems. And we're done reviewing for now, so we'll hit up unit tests starting next week. Have a good day, I'll see you tomorrow.